Now the first topic regarding Laplace transform is the Laplace transform of a constant function. Let's first we start with the definition of Laplace transform. So this is the definition of Laplace transform. Now this is the definition of Laplace transform. We have a function f of t and just replace the value of this function over here and solve this improper integral. If this improper integral converges, then that will be the answer of this particular function. So we are considering here the constant function. So let's start with a very simple example. If the f of t is just a number 1, so what will happen? Just insert this function into the definition and we have now this is the only thing left and we have to solve this integral. And this is an improper integral. So keep in mind, you can convert this integral into the limiting form and now integrate e raised to the power minus st and make sure here s is always positive. You will see the integral of e raised to the power minus st will be equal to this one, and we will apply the upper and lower limit over here. After simplification, what we get? E raised to the power minus s to the tau minus e raised to the power minus s 0 divided by minus s. Further simplification will lead to the final stage. After simplification, we will get e raised to the power minus s tau. Here you will get e raised to the power 0 divided by negative s. Then further simplification, we will get this factor. Now apply the limit and definitely e raised to the power negative infinity will be 0. So we left to here 0 minus 1 divided by negative s, and the final answer will be 1 over s. And we all know e raised to the power negative infinity always equal to 0. So due to this factor, we have found the Laplace of a constant function, and that is 1. Similarly, the next, if we take any other number. For instance, if we have 5, it is a positive number, and what will happen? Similarly, you can easily find the Laplace transform of 5. It is very simple. You can take 5 out of the integral and then solve this integral as we have solved before. Just take the limit and then solve this particular exponential integral, and we will get after simplification or integrating this exponential function, we will have further simplification lead to the final result. So finally, after inserting the limit, what we have this, and finally what we have concluded, the Laplace transform of 5. So this shows, so Laplace transform of 5 is always equal to 5 over s. And before that we have proved Laplace transform of 1, that is equal to 1 over s. So it seems to us that whatever the constant is, further we can easily calculate the Laplace transform of a, and I am sure the Laplace transform a will be a over s, where a is any constant. It may be negative, it may be positive, it may be a rational number, or it may be an irrational number. So you can conclude that, so this will be the final formula for every constant. So in this way you can prove you don't need to find the Laplace transform of simple constant one by one. You just solve this formula and just prove this factor. If you have proved this one, so this Laplace transform of any constant you can calculate. Prove Laplace transform of any constant, that will be this one, where a is any constant, any constant. So according to the definition, you just need to insert the function of t, that is a, here, and just take a out of the integral, and the remaining improper integral will be in this form. If we will use the limiting case, and then 0 to tau e raised to the power minus st, and we have proved multiple times in the preceding example. So you can easily finalize the final answer for this integral, you will get e raised to the power minus st divided by negative s with 0 to tau. After simplification, what we have left, of course, since we have done before 2 times in 2 different examples, so what we have left, of course, we have left e raised to the power minus tau e raised to the power minus 0 and divided by negative s, and if we apply the limit, what will we have? We just have e raised to the power negative infinity with e 1 and over minus s. Finally we will get this result, and this is our proof. So in this way you can calculate the Laplace transform of any constant function by using the definition of Laplace transform.